Chapter 11 is about gases. And first we're going to talk about drinking soda. Anybody actually read this chapter in the book? Oh yeah, everybody read it, right? So the author talks about when he was a kid and they went to restaurants and he always got orange soda, and what he liked to do is put a bunch of straws together. You know, you pinch one end and stick it in and make extra long straws. And of course his parents weren't big fans of that, but he liked to put his cup of soda on the floor and stand on the chair and drink through the straw. How long of a straw could you do that with? You know, could you be on top of the building and do it? Could you be 5 stories up, top of the Empire State Building? You know, how long could you do that? And exactly how does a straw work? Have you ever thought about that? How does a straw work? So we're going to talk about that. One of the things that happens when you suck on a straw, there's air in the straw. Here's a straw, but I drank everything already. There's air in the straw. When you suck on it, you're removing the air that's in that straw and causing a pressure difference. And then the soda comes up, and so we're going to look at why the soda comes up. Even if you had a perfect straw, you know, one long piece with no leaks, and it had rigid walls so it didn't collapse like the straws collapse when you try to drink a Jack in the Box milkshake. You know, it's too thick, and so you suck on it and it just squishes, right? So a nice rigid straw, and even if you could do a perfect vacuum, you could only get the soda to go up about 34 feet. And beyond that, it just would not go up. The straw would not work. It was 10.3 meters, if you care. So we're going to think about what are the gases doing, the gas particles, and what is pressure. Here's an illustration of gas particles. So there are gas particles in this room. There's air, thankfully. We're all breathing it. And they're zinging around. They cause pressure. They cause pressure because they run into things. And pressure is the force on a certain area. And so they collide with the surfaces. They're colliding with your body, with the ceiling, with the floor. The air is exerting a pressure. We don't feel it because it's always there. And at sea level on our planet, that pressure is 101,325 newtons per square meter, which probably means nothing, or 14.7 psi, which you probably are a little more familiar with psi. So what does gas pressure have to do with drinking soda? It was funny yesterday, I gave this lecture at COS, and one of the girls in the front row was drinking orange soda. It was just kind of funny. So here's an illustration of drinking orange soda. When you put the straw into the soda, some soda goes up initially, right? And so you've got soda in the straw, you've got soda outside the straw. You have air outside and you have air inside. And the pressure of the air inside and outside is equal. When you suck on the straw and take some of the air out, then you lower the pressure in there. But the outside pressure is the same. And the outside pressure is pushing down on the soda. And so the soda's trying to go somewhere. Well, there's less pressure in the straw, and so it goes up. So when you're sucking on the straw, what you're doing is you're lowering the pressure and enabling the atmosphere to push the soda up the straw. Probably never thought of it that way. So if we had a perfect vacuum, so here's a vacuum pump and a long rigid tube, and here's our probably be like a swimming pool of orange soda if this is 10.3 meters. That must be pretty big. So you have atmospheric pressure, the pressure of the atmosphere pushing down, and if you pull a vacuum on here, then you have no pressure pushing down there, but you do have gravity pulling down on the soda. And so the soda is going to rise until the force of gravity pulling down is equal to the force of the atmosphere pushing it up. So it's only going to go up as far as the atmosphere can push it up. And at sea level, that's about 10.3 meters. So it'll rise 10.3 meters and no farther, no matter Even if you have a perfect vacuum up here, it won't go up any farther. So the atmosphere pushing down is what causes that to rise up. Does that make any sense? Probably never thought about it that way before.